Recording started.
Okay, can everyone hear me okay? Awesome. Seems like something of a select audience this evening. So I'm hoping that means people are working on their assignments. Yeah. But I do have some news. Several bits of news, really. So the first bit of news is that I'm about halfway through marking your debugging assessments, and so I'm hoping to get them out this evening. At the very least, I will have the marks up on Blackboard. If I don't get around to the actual modifications to my script to actually get them out, get the actual feedback out. But yeah, oh yes, very much so. Yes, that's one of the features of that assignment that I try to really encourage people. It's a bit of a carrot, right? If you spend time on the debugging assignment, not only will you boost your marks, but you end up doing better on assignment 2 because of everything you learnt while doing the debugging assignment. And I can say so far I've got about 15 out of 40 marked, and the average mark is about 8.6 out of 10. Yeah. Well, memory issues more generally, which is like, hey, majority of the additional problems you have with C programming over other languages is the fact you have to learn to manage your own memory. Yeah. So that's the big issue there. Now, this week's material has not historically been assessed. It will be assessed this time. And part of the reason for that is we no longer have hurdles, so I have to have other levels of quality assurance in terms of people passing and all that kind of stuff. You may realize that this week is the last week, or you may or may not know, but this week is the last week of new material. And next week I will be essentially coaching you with exam stuff. I have several exams already up on Blackboard, and I might just show you that. If we just go into assignment/exams, and I might just hide things which you can't normally see. So we have this exam. So the stuff for the exam is actually on the say Titan Jupyter Saturn servers in tilde E70949/shared/exam. Yeah. Well, I guess the thing to keep in mind is that this year is going to be a 2-hour exam rather than 3. So some of those exams might be 3 hours. So if there's 5 main questions, it's a 3-hour exam, and if there's 4 main questions, it's 2 hours. Because basically I've made less stuff on linked lists, so I've made the linked list question shorter and cut out one other question. But we will get on to that next week. This week we want to actually deal with one of the topics which is actually going to be on the exam, and that is generic programming. So what do you think I mean by generic programming? Yeah, correct. Programming that doesn't rely on specific types. Up till now, we've given you scores or ints or persons or what have you. And what we want to do is we want to be able to write... But you see, if I had to write a new linked list for every new type that I wanted to store in a list, do you think that would be a good use of my time? Be a major waste, wouldn't it? Right? And so what we'll do, I have it. Yeah, I have it here. Oh, look at that. And I'll just alrighty. So, by the way, there is a tutorial sheet for next week, but it's purely for those who want to be a bit adventurous on writing your own kind of printf and that kind of stuff. It's not actually examinable material, so maybe keep it aside for something to do once the study period's over or something. Up to you. But here we go. Here's our... Okay, I'll close that one. So, if, we've used this kind of example quite a bit in the course, where we've had the idea of a struct person. Now, let's kind of think about this one here, right? This is more of an array list kind of approach. So what do I need to change in this structure to make it a generic array? In fact, what I might do is okay, so we're probably going to need a person.h and so we've got our struct person, which we've seen 1,000 times before. Right, and with our define name len 20. Right, and our char f name and obviously we all know what that +1 is for, right? Yep, for the null terminator. Okay, so rightio, in the past, what we like for this person array, right, we would have hash included person.h in here, right? But actually, the idea is, in fact, to get rid of all that type information from the list. So what's the type you reckon we're going to use instead of a person? Correct, void star. Now, the thing is, there is no such... Now, you know that the void type means nothing, right? Yeah? When we return void, we return nothing. That's what that return type specifies. And because of that, we can't have a variable of type void, but we can have a void pointer. It's basically a pointer to stuff. So if you want to see, every time you see void pointer, to see it as a handle. Have we seen void pointers much before in this course, do you reckon? Yep, we just haven't talked about them. Okay, so void star array, say. And look, we'll make it a fixed size array, make our lives a little bit easier. You probably want to play around with... Yeah, so you might want to play around with dynamic arrays beyond this course, but I've decided in the assessment for this course to stick with fixed size. Hang on, no. What am I doing? Not namelen. So num elements. And we'll make that say 20. Right. And okay. Do we need anything else in here? Any other variables, you reckon? Well, the void pointer from malloc you can assign to any other pointer type. I consider it a good idea to cast the return, mainly because that makes it clear the type of pointer it should be assigned to. But casts actually don't take any... They're simply part of needed for compilation. They're not actually... There's no such thing as a cast in an executable. Anyway, right? It's just types which actually make things a bit safer for us. And that's all. Okay, let's say size T current size, right? Because even though we've set this to be a fixed size, we've got no right to actually assume that all of them have been initialized. Maybe none of them have. Okay. Rightio, and I'll just throw this in a include guide, which just means that if I try to include this file twice in the same .c file, it will only be included once. And it's probably a good idea to actually say what it's for. Okay, alrighty. So that's our list. So let's build up this list and actually have a look at what the implications are for a generic type or a generic container like this. So you remember what the four kind of operations we tend to define for all our containers? For all our lists? No, the four operations, see, it's really interesting. I find this fascinating. That when when we go from arrays to linked lists and then we go back to arrays again, people start talking about nodes and things which are about lists. Yep. Okay, that's a reasonable set, but again, that thing that a list is simply an interface, which is something which everyone should be coming to grips with their assignment, because I have to deal with that concept. How are people going with that anyway? Any problems with your assignments? Okay, so we'll, as per that's simply being a programmer, I reckon. That you have lots of bashing your heads against the wall kind of moments. Yep. If the code, like, well, from a point of view of learning, if you're not having those moments, then you're not learning, because they're the hurdles you need to jump over to build your understanding. Now, that's probably not the most reassuring thing in the world to hear, but I can tell you that it's an ongoing thing. In many ways, I would say that I probably know C better than most people I know, but I still have those moments. It's a very rich language. Anyway. Yeah. Okay. So what I'm doing here, so I'm actually going, okay, I'm leaving some things out. And we're not going to implement everything. We're not going to have time. Oops. No, that's right. And save. But we're going to need, one of the things about a void pointer though is we don't know the details. We don't know the internals because it could be any old block of memory. So generally, precisely. So do you remember how I've been writing my comparisons up until now? Like if it wasn't an int, what kind of thing have I been doing? I might have used some kind of a function, like a comparison function. So a comparison function kind of in the model of memcomp, strcomp, etc., etc. So and in fact they're all modeled on the comp assembler construction. So what do I mean by that? Well, the way, or if you want to see it this way, they're modeled on subtraction because that's what that's how the CPU can only use, is basically a really fast adder and subtractor, right? So comparison functions, oops, int comp yeah, does that make sense? So this is a way we can enforce some kind of comparison where if the thing on the left is less than the thing on the right, we'll return a negative number. If the thing on the right is greater, it's the thing on, so it's, if the thing on the left is less than the thing on the right, well then that's a negative. Yeah? If the thing on the left is greater than the thing on the right, then that's positive. And if they're the same, we return 0. Just like integer subtraction, a minus b. So if a is bigger, we return a positive number. If b is bigger, we return a negative number. Same idea, right? Therefore, going back to our person.h, what we might do is actually add for now, what we'll do is declare a person comp. So what kind of parameters do you reckon this should take in order to work with our generic list? So we'll go back to our generic list. Is this going to know anything about persons? Right. Therefore, over here, what I would do is specify that it's going to take 2 void pointers. And I'll just show you what that function looks like. Okay. So we'll include Good question. Now I just have to say to you that one thing I noticed when I was marking some of the debugging assessments is people went, oh, you've got const there, that's obviously a bug, I'll delete the const. And they submitted that as a bug fix. Now, does anyone know what const is? Yeah, let's be more specific because the word means something slightly different in different languages. Yes, it is read-only. Read-only. So, why, therefore, do I have these as consts, do you reckon? Should a comparison function change its the contents of the things passed in? It's just doing a comparison, right? Yeah, so really is illegal for it to modify the data. Therefore, this is what's called programming by contract, right? There is a contract between whoever calls person comp and the person comp function, and part of that contract is I will not modify your data. The other part of the contract is that really, under the hood, these pointers you pass in must be person pointers. They cannot be int pointers or... Because if there's some other kind of pointer, I might do something bad with that memory. because it will have a different memory layout. Right? So, we're still faced with a little problem, aren't we? So we can actually decouple our function, our management. So yeah, right. So but the void pointers. This is so that we can actually write data structures without a type. And please, if you're coming in late and you're asking questions which have already been covered, that slows down the chat for everyone else. Anyway. So can I just do, say, what do you reckon? Now, the underlying thing is that in fact the list needs to have a pointer to the right function. So we'll have a look at that in just a moment. But is there any issue with what I've typed here, you reckon? What's the problem, Josh? No, there is a problem. Okay, it might be a little bit tricksy for you. I must make this const, because otherwise I'm removing the const from above. But can you see something else I'm doing here? What's the thing that I am assigning? So, you know, if we think about left and right hand side of an assignment. So what's the type of person A? And what's the type of PA? Well, is that legal? It is, actually. I was being a little bit tricksy there, sorry. Because you can assign a void pointer. You can assign a void pointer to any other pointer type. You can assign any pointer to a void pointer. So it is a container, or it can hold the address. It can hold any address. Yeah, kind of. But now I can actually have my logic for comparison. So let's just say int comp equals, okay, we're going to need to include string.h. So string comp PA. Oh, look at that. Let's start with the last name, hey? Oops. Yes, a little bit. So, do we remember what strcmp returns? It's not the length of the difference, it is in fact simply a signed difference. That is an int if the first number, or if the first word is earlier in the sort order, then we'll return a negative number. If the second is early in the sort order, return a positive number, because it's just subtraction. That's the whole idea. So if comp right, or if comp not equal to 0, and similar thing again. And then return comp. But you see that that this function can be called where we don't where we just pass in two bundles of stuff which are in fact persons, but our list doesn't need to know about that. So how are we going to let the list know what function to call for comparison? Yep. You knew I was heading over that way. So what I might do, in fact, is in my init, I may in fact pass in some function pointers. So what was I want a pointer to a function that takes in two void pointers and returns an int. So int, there is multiple kind of syntaxes for function pointers. This is the syntax I will use. Oops, I've made a mistake. What's my mistake? Been talking about them a bit tonight. Const, correct. This will not match what I specified. Okay, now I'm going to therefore need to pass in some void pointer data. I'm not going to worry right now about this function. Because we were not going to have time to have a look at it, but the principles I'm showing are the same. On here, so let's have a look then at my list init. So tab new list.c, and let's just define these two functions. Okay, and we will hash include list.h. And let's write the function. Oh, that's an interesting point. Where am I going to store my... So I'm passing in this function pointer, but where am I going to store it? Where do you reckon? Because I'm passing it into list init. So the issue is, what structure am I going to store it in? Okay, so let's just throw it in here. And okay, was now set, like this syntax, a lot of people find it really ugly and a bit hard to follow, but I can say actually I'm going to type def int compare func right. So now I have another type called a compare func. So you know down here where I've got this big long viso, I can just get rid of all of that. And say that the other parameter I'm going to pass in here is a compare func. And we'll call it func. Reckon that's easy to read? And I like to be consistent, So I'll actually delete this here, and we'll say compare func and then I can in fact put a function pointer inside my list struct. Right? So we start to see, in fact, for those of you who have any interest in going on to doing C++, in fact, this is how objects are represented, is in fact, they're just pointers inside a struct, like function pointers, pretty much. You know, like methods and all that kind of stuff. Okay. So now, this size, or was that what it was? Current size, okay. And list compare equals comp. Now remember that in fact a function name is in fact a function pointer, right? So that means that if I pass in the name of the function, so I'll just, let's say we've got a main.c, and I might hash include list.h and hash include person.h. Remember that the list doesn't know about the person, so we have to do that work. So struct list my list, list init. So what do I pass into list init? My list, what else? Do I need to pass anything else in? Correct. Now remember that because I'm including person.h, I know about this person comp function. And its name is person comp. So over here, yeah, And so now that is in fact part of the struct. And say, okay, over here, let's also have struct person star make person. Well, it's all the same stuff, really. People who think that C is not a language which can express abstraction don't know C. It's quite, and there's a lot of people who claim to know C that don't know it. That's the truth. Anyway, well, no, it's a this is the ISA versus HASA relationships, yeah? That in fact our list has persons. That whereas a subclass would be if a list was a kind of person. That's, yeah. And let's just say that we have char fname, char name, int h. And we've seen that before, so I won't bother doing it. It's just a malloc and then copying in the data. So over in main, I kind of, okay, struct person star new. New equals make person. I'm so predictable. Right, so and then we would add that person using, well, remember we've got to check if it succeeds. So if list, if not, list add into my list new. Okay, so what I wanted to spend the rest of the time doing is having a look at a list add, because I feel this is probably, for those of you still working on the array list section of the assignment, this might be helpful. Because yes, we're using generic, so that's something that will be new, but the array list stuff, we'll have seen that before. Okay. So what we want to do here is we want to insert in sorted order from the lowest to the highest. So what kind of things do I need to do in here? It's mostly the same. You've seen all of this code before. Many times. Okay, well, we've already, we don't need to do any allocation in this case, actually, because we've got the data, and we've got a fixed size list. So either there's going to be space in the list for us or there's not. Yeah, good. So if, now it's list, not behaving well for me tonight. So if list current size, and what was its num elements, okay, we know the list is not full, so what are we going to do now? Remember, we got to search for the insertion point, right? Okay. Yep. So if then list array 0 equals data. You notice that because it's just some pointer type, we can just assign it. Just a memory address. Nothing new here yet. Right, okay, this is the bit, isn't it? So let's have int index. For index equals 0, index is less than, oh, less than which? Ah, very good point. Okay. So index is less than what? Yep. Yep. So we're looking for a condition which is if what? This is where our function pointer comes in. list compare. Oh yeah, yep. If list compare so we're going to compare the index with the data right? Is that looking good? Okay, so what do you reckon's next? Oh yeah. Yeah, we can do that there. Int back count. Yeah, I tend to do things different each time, hoping that that will rub off on, you know, different ways that you can actually do stuff. So what should back count start out as? List what? Yep. Back count is greater than count. Index. My bad. Yep. And so, list array back count. So we're doing the shuffle shift. And then list array index yep. Okay, we can just return true in here. So what does that mean there then? If we get to the end of the list. Yeah, my bad. Don't know what land I was in just for a moment there, but thank you. So what about down here? The issue of what to do if we get to the end. Yep, it sounds reasonable because we know there is space or we would have failed at the start. We've got through to the end and this element is larger than anything else in the list. So it is reasonable to put this yeah, and it needs to be a post increment. Okay, so does that look pretty cool? So other things you might want to play with is turning a array list. So it's turning your linked list generic. It's actually easier. About the same really. But there are quirks and things you need to deal with. One thing I want to actually cover before we finish off is I want to look at a function called array walk. So okay, walk.c and okay. So the idea with an array walk is we want to be able to process any kind of data. We want to be able to write helper functions to actually walk over any kind of array. So when you think about some type, right? So we think about some type bar, where type is a type name. What information do we get from that, from the type name? Good. Size. Size is all important because if you don't know the size of a thing, you cannot allocate a thing. Yeah. So, for example, have any of you had a problem with dereferencing a pointer to an incomplete type? If you have that problem, it's because it doesn't know. It knows the type exists, but doesn't know how big it is. So if someone does something like this, struct foo. So now that says that this type will exist at some point, but it doesn't actually say what's inside it, and until we get a full declaration, we can only have pointers to it. We can't actually have like arrays, because arrays need to know how far apart each element is going to be, because that's how arrays are allocated. We need the actual size of each thing, or we can't actually allocate an array. So what we're going to do is we're actually going to write a function that can process any array. And hold on to your horses, because the prototype's another fun one. So void actually this is a function that is implemented in the PHP standard library. Don't know if anyone might have used it, but basically it takes in an array and it takes in a function, and it walks over the array performing the function. Okay, so let's just say we have a void, so we have our base pointer. Oh, let's just call that the array. That's our array. Now, remember how we said we don't know anything about size of the elements? Well, we need to tell it. Size t alt size. Size t num alt. Can anyone remind me what a size t is? I've been using them a bit lately. Well, it's an unsigned long, and it's guaranteed to be large enough to store the size of any chunk of memory. It's returned from size of strulen. It's taken as an argument into malloc. Anywhere that sizes are being talked about in a standard library, size t is used. Sometimes I might use s size t, which is just a signed long, so it takes one bit to use for the sign. Yeah, they're different. I try to use size t's only for size, not for like for loop iterations or anything like that, because they're actually slower. I can, yeah, I've seen discussions about why they're actually slower. Okay, so we have a number of elements. We have the size of each element. So we've got all the information we normally need for an array from manipulating it, right? We've got the size of each element, which we would normally have from the type, but we don't get access to that. And now let's actually get the most fun bit. Void action. Right, so we're going to have a function called action, which performs the action on each element of that array. And it doesn't matter what its type is. Right? Well, we will handle the type through this action function. Rightio. Now we'll include walk.h. And we will start our work. So this is a void array, void pointer. So we don't have the right, it is illegal to use a void pointer in pointer arithmetic. Why do you think that is? Correct, we don't know the size, and therefore it's invalid to talk about size. In fact, what a lot of libraries do these days is they actually, if they need a block of generic data, they'll actually use char. Because we know the size of each element of a char array is 1 byte. And so that's a common approach. So, okay, we're going to have so we'll say current is the array, right? Now this is a little bit of tricksy mathematics, but hopefully we'll get it. So you know, you should know that you can actually leave out parts of your for loop, right? So here I'm leaving out the first part. Actually, no. Actually, what I'll do, now this could be, sometimes this kind of thing is a little bit buggy. Actually, I'll use a long, just it's a little bit safer. Okay, so if we're iterating over the elements, the current index must be less than what? No else is right. Yeah. Because the size of each element tells me how far ahead I need to jump in memory to get to the next element. Just exactly like array subscripts are really pointer notation. Right? So if you've got some int array, right? We know that from array 0 to array 1 is exactly size of int. Yep. Everyone comfortable with that idea? Yeah. So we need to manually perform that same task. We have taken over responsibility for type management from the compiler. That's what generic programming is about. Well, it's what it ends up being in C. Rightio. So now, okay, let's do the easy bit first. Action on current. Oh, that was easy. But how do we now increment? How do we now move on to the next memory address? I don't expect anyone to be able to answer this bit. But it is the hardest bit. So I have current equals char star. Oh, that will be one to ask you about. Current plus alt size. Okay, so what on earth is Paul on right here? What's this mean, you reckon? It's not really all that different to if I had down here int star pointer equals array same kind of idea. Well, there's no allocation. This is simply handling the pointer arithmetic. We cast to a char pointer because how big's a char? What size of char? Well, it'll return 1. Size of char will return 1. Right? So what we're saying here is the cast here is only required in order to make the pointer arithmetic work. It doesn't modify anything. If there's any modification, it happens in this action on current. Because we can't use the void pointer because void pointers have no size. Or to be more specific, you will get a compiler warning if you use it, which means you shouldn't use it. So what we do is we cast to char Because in a sense, char is also a kind of generic type in the way we're using it here. I do this all the time in various applications where I copy data, use memcopy to copy data into a char array. So I can pass that around and then copy the data back out of the char array. And this is a common technique called marshalling, which is often used when we want to be able to copy or store data in a generic manner. Okay? But we don't have the full picture yet, do we? We've only got the walk. We don't actually have the function action. So let's work on that. And okay, we know that the function prototype required for my array walks is void. The function must return void and must accept a void pointer as a parameter. So let me just have some functions here. Void double add 10 void double sub 10 void int add 10 Okay, so I've got a series of functions which I will actually define a little bit later. I'm just declaring them for now. And what I'm going to do is I'm going to, let's get rid of that foo that's not really got to do with what we're doing here, and I'll include walk.h, and what we'll do is we will let's also have two more. Void print double void print int okay. So these are all functions we're going to implement that actually do stuff for us in a generic manner. So can anyone guess what variables I'm going to declare in here? Well, I'm going to have an int array equals 1, 3, 5, 6, 8, 9, say, and double array equals, oh, forgot the semicolon, 1.1, 3.3, oops, 3, 5.5, 9.9, oops, and let's finish off with 3.14. So let's see, we've got 1, 2, 3, 4, 5, 6. Okay. Point 101010. No, it won't. So 12.1. That'll do me. So I've got two arrays. One's doubles and one's ints. And what I will do is we'll start off array walk, print. So what we want to do is we want the int array. So what are our parameters we've got to do here? So the element size, so size of int 6, print int. And let's actually learn how to spell properly. Okay. Double array, size of double, and what I'll do is actually I'll copy all of these, and down here what I'm going to do is implement them. Okay, now before I actually assign to a local variable to do various things, I'm not going to do that this time. What I'm going to do is cast to a double num, and then dereference. Right. So everyone understand what I'm doing here? Because this comes in as a void pointer, I have to cast, well, I either have to cast it or I need to assign it to a double pointer. Likewise here. Okay, then int pointer num and let's just say what we'll do here is printf %f tab and likewise here. So is this making sense? The main thing that we're not needing, that we're taking over responsibility for handling of the types. Okay. So they're all of the little functions that help us. So now say for example array walk, what we need to do here is double add 10 and just we'll replace this and then one more of these, two actually. Just got to be very careful with your sizes or you'll mess things up completely, as I was about to do. So it's very error prone is part of the issue. And why actually most languages have moved away from this kind of approach. Even C++ uses something different. Templates. So print int double array, print double. Okay. I think that's all of them. That should do us. Okay. The only other thing I want to do is let's add a new line character. Actually, let's add 2 because it'll make it easier. Oh yeah. So let's now see whether this actually compiles or what level of disaster I have become. Okay. So GCC ANSI wall pedantic star.c minus O walk. Okay. So I have a feeling that I need pretty sure it's in standard lib. Okay, let's see what the story is. If we just go down here, aha. Yep. Okay. So we start off with our ints 1, 3, 5, 6, blah blah blah, and our doubles 1.1, 3, and so on. Then we add, I call add 10 for both. Yeah. And then we see that they in fact have added 10 onto each. So that's pretty powerful. Yeah, so what I will definitely say is that this material, in one of the forms which we have seen it today, will be on the exam. So while it's not assessed in the assignments, because we only get to it like, you know, a week before it's due or something, it's not fair on you. Instead, we will have, some small questions, maybe 15 marks out of the 120 that is focused on this topic of generics. I kind of have today given you examples of, there's not a lot more I can give you than kind of the examples from today. They give you a bit of an idea of the kinds of things you might be asked. Yeah. What I would say is, as well as this material, perhaps do something like, for example, take a linked list which you've already got and make it generic. In a similar way to what I did with the array list today. I'll see if I can dig up some old questions as well. I'll see how I go with that, because it's probably been a few years since we've examined this stuff. But I think I did that in 2013, so I should actually have an exam paper sitting around somewhere with that material. Okay. I might leave that there. Perhaps if anyone's got any kind of assignment questions, I'm quite happy to answer them now. Hopefully you're well on your way to completing the assignment. It's not far away till it's due. Are there any particular issues anyone's facing at the moment that they've been struggling with? Yes, I will do that. Yep. It's not a problem. Yeah, it's a nice little program, that one. Sure, okay, so this was in array walk. Actually, why don't I actually be one above? Person array and array walk. And there is actually some previous generic code up there anyway, but I'll move these two in there. And then go into ch mod 755 array work and person array. You should have access to that now. Yep. Okay, so there's not a lecture for week 12, but what there will be is a chat where I will I will walk us through the exam materials. And what I expect and all that kind of bizzo and what you can expect. Okay. Cool. So, unless someone's got some burning questions about the assignment, I'm about halfway through it. I'm actually hoping to finish it off tonight. So that's got a little bit of work to do still, so yeah. Cool. So I might just head off so I can actually do that. No worries.